Most people believe that battery chemistry controls depth of discharge, with common misconceptions like lead-acid batteries can only discharge to 50%, while lithium can go to 80 or even 90% depth of discharge. So if they want a deeper discharge, they need lithium batteries. This thinking has cost people thousands of dollars in unnecessary battery upgrades. This is a 12 volts lead-acid battery that is still powering the inverter at 11.5 volts. Even at 11.5 volts, the 12 volts lead-acid battery is still showing a green light and powering appliances effectively through the inverter. At 11.5 volts, the 12 volts lead-acid battery has already gotten to 90% depth of discharge at 10% state of charge. If lead-acid batteries truly have a depth of discharge of 50%, which is at 12 volts, the battery should have stopped discharging at 12 volts by shutting down energy release to the inverter. This is to show you that battery chemistry is not what controls the depth of discharge. Let me know in the comment section if you have ever discharged your 12 volts lead-acid battery below 12 volts before, and still join the crowd to say that lead-acid batteries only have a 50% depth of discharge. Was it lack of understanding that made you say that, or just following the crowd? In this guide, we are going to reveal and learn everything about what actually controls any battery's depth of discharge. Different battery chemistries have different discharge characteristics, but that's not what actually controls how deep your battery discharges. The real battery's depth of discharge controller has been hiding in your inverter settings all along. Meet your battery's real boss, which is the low voltage disconnect, LVD, or cutoff voltage setting in your inverter. In lead-acid batteries, the low voltage disconnect is controlled by the inverter settings. In lithium iron phosphate batteries, the low voltage disconnect is controlled by the BMS and the inverter settings. That is why it is always advisable to use programmable inverters and avoid sachet inverters. This is because with programmable inverters, you can adjust settings like the low voltage disconnect. For example, in this programmable inverter, the cutoff voltage, which is still the same thing as low voltage disconnect, is set to 10.5 volts. I can still adjust it to any value I want it to be. But in sachet inverters like this, you cannot adjust the low voltage disconnect value. This is dangerous as most of these sachet inverters can discharge below 10.5 volts. Low voltage disconnect, LVD, and cutoff voltage are the same and are used interchangeably. This little setting determines exactly when your inverter stops drawing power from your batteries. This is a chart that shows the depth of discharge for a 12 volts lead-acid battery. For a lead-acid battery, the battery is already at 50% depth of discharge when it is at 12 volts. Does this mean that the battery will shut down here? No, it will not, if the low voltage disconnect in the inverter is not set to 12 volts. If the low voltage disconnect of the inverter is set at 10.5 volts, like what we have in a lot of inverters, the battery will stop discharging at 10.5 volts, which is 100% depth of discharge. Here's how it actually works. As your battery discharges, its voltage drops. Your inverter constantly monitors this voltage. When the voltage drop hits the LVD threshold you've set, the inverter cuts off power output to protect the battery. If you set your low voltage disconnect to 12 volts on a lead-acid system, you are getting maybe 50% discharge. If you set it to 11.5 volts, you are at 90% depth of discharge. Same battery with a different depth of discharge, all controlled by that one inverter setting. Let me show you this in action. In most inverters, the low voltage disconnect is set to 10.5 volts. This means that the inverter will shut down when the battery voltage gets to 10.5 volts. You can still change the LVD value to 12 volts, or a higher voltage. The inverter would now cut off at a much higher state of charge, giving us maybe 50% depth of discharge instead of 0% at 10.5 volts. Same battery chemistry, completely different depth of discharge, and different performance. This isn't just technical trivia, this is money in your pocket. In that lithium battery upgrade you thought you needed for deeper discharge, maybe you just needed to adjust the low voltage disconnect setting in your inverter. But here's the critical part. Battery chemistry does matter for longevity. A lead-acid battery discharged to 80% repeatedly will die much faster than one discharged to 50%. Lithium batteries handle deep discharge much better than a lead-acid battery. So while your inverter controls the depth of discharge, your battery chemistry controls whether it survives that discharge depth long term. To help your battery serve you longer, there are certain LVD voltage range you should maintain depending on your battery chemistry. For lead-acid and AGM batteries, maintain LVD between 11.5 to 12 volts. For gel batteries, Maintain LVD between 11.5 to 12 volts. For lithium iron phosphate batteries, maintain LVD between 11.0 to 11.5 volts. Remember that these are starting points. Your specific battery manufacturer might have different recommendations and factors like temperature and discharge rate, which you should also pay attention to. Many modern inverters have programmable LVD settings. You can set different cutoff voltages for different load levels. For example, set a higher cutoff voltage under heavy loads to protect the battery from voltage sag, and a lower cutoff for light loads to maximize capacity. Even better, some systems can use state of charge-based cutoffs instead of just voltage. This accounts for battery aging and gives you much more precise control. There are some common mistakes to avoid when setting the low voltage disconnect value. Mistake 1. Setting low voltage disconnect too low for your battery chemistry. When you set the low voltage disconnect very low to values like 10.5 volts, you get more capacity, but you will kill your batteries fast. Mistake 2. Assuming all batteries of the same chemistry can handle the same depth of discharge. Different battery chemistry handles depth of discharge differently. Some batteries will still last longer when discharged below some levels. This is common for lithium batteries. But the same thing cannot occur with lead-acid batteries. When you discharge a lead-acid battery below certain levels, the longevity of the battery will be highly reduced. Always check manufacturer specifications of each battery. Mistake 3. Setting low voltage disconnect value and forgetting. Battery characteristics change as they age. As the battery completes more cycles of recharge and discharge, the capacity also reduces gradually. This can be done by performing a capacity test on the battery periodically. This can be once in 3 months or once in 6 months. When this is done, you will observe that the same load that the battery could power for 5 hours is now being powered for 4.5 hours. This shows that the battery has lost some capacity as it keeps completing cycles of discharge and recharge. This will require you to also adjust the depth of discharge to help it last longer. Always make sure you perform a capacity test and revisit your low voltage disconnect settings periodically. Mistake 4. Setting low voltage disconnect value too high. When the low voltage disconnect value is set too high to voltage above 12 volts, the battery backup time will be low, but the battery will last longer. A high LVD value may be efficient in a grid-tie inverter system, but in an off-grid system, this will lead to a lot of backup time issues. So remember that your inverter's LVD setting is the real controller of depth of discharge, not your battery type. Battery chemistry determines how well your batteries handle that discharge depth over time. Before you spend thousands of dollars on a battery upgrade for deeper discharge, spend 5 minutes in your inverter settings. This is because you might already have the capacity you need. If this saved you from an unnecessary battery purchase, hit that like button, subscribe for more battery system truths that can save you serious money. Drop a comment and tell me what your current low voltage disconnect or cutoff voltage setting is and what battery chemistry you are using.